Good morning, good afternoon, and good evening, wherever you are. Thank you for joining. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Apptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source.
Oh my goodness, you guys, we made it. Welcome, everybody. Welcome. Okay, and welcome everybody at home or in your office or wherever that you are watching in the world. Today is a hot topic. Okay, we're going to be talking about kernels, frozen kernels, vendor kernels, bugs, stability. And I just want to throw out real quick for everybody a little disclaimer, which I think is in order. Right? There will be opinions. There will be opinions based on all kinds of things. It is not necessarily the opinion of CIQ as a company or Rocky or even the software, open source software organizations in general. So all four of us do work at CIQ, and we're going to get into introductions in a moment. But this is a really, really fun topic. I mean, this is wild, right? I was at the store the other day buying a new iPhone. I don't know if I recommend it or not, but that's what I was doing. And one of the guys asked me what I do. And so I was telling him a little bit about our company. He was like, I have no idea. He didn't know what Linux was at all. He works at the Apple store, right? So I was like, okay, this is kind of funny. So I was like, sort of trying to explain it to him, like what we do and what's happening. And it was really cool. And I mentioned like the kernel, and I felt really smart. And I was like, well, you have your hardware, and you have all the chips, and you have like the binary code, the ones and the zeros. And then you need to have something that like takes all of that and translates it into something that human beings can understand. It's like in between the operating system and the hardware. And like, that's the kernel. And the guy's just looking at me like, that totally makes sense. So the brilliance of the three of you, we're going to be talking about that in a moment, is very exciting. The second thing I'm just going to barge in here real quick is if you like these kinds of topics and all the things that we're bringing to you each and every week, and you're already a subscriber, if you go and you're on YouTube, if you go in there and you click on the notify button, then you won't miss anything. It used to be that you could come in and you just subscribe and then you get notified when all the, different places on YouTube that you subscribe to would notify you, but you actually have to click the notify button now. And if you're not a subscriber, hello, subscribe. We want you, we need you, we love you. Click the little subscribe button and you'll be able to get notified. Click the notify button. Okay, so now we're getting into it. We're going to do a little introductions. I will let you all introduce your beautiful, amazing selves. And just for simplicity, I'll just call on you. So Jeremy, you're the first one on my screen. Why don't you introduce yourself?
I'm a distinguished engineer at CIQ. And to be honest, what that means is I get to do the stuff that nobody else wants to do.
Well, thank you.
I get dragged into just about everything. So anyway, I'm with that.
Oh, that's awesome. Well, that's probably what happens to all three of you, right? Like when you really understand the low level kernel stuff that we're going to be talking to today, and then it's like you actually can do everything on top of it as well. So thank you for that. And Mr. Maple.
Sure. I'm a senior software engineer in the kernels specifically. I also get dragged into everything, but more from a how do we scale out kind of situation and make sure that we can continue to grow at a clip so that we're not either wasting our resources with, people have nothing to do, which is never a thing at a startup.
And you have the most interesting background of all of us.
Maybe.
Maybe. We got a lot of very interesting people here. And Ronnie, welcome. This is Ronnie's first time on our webinar. You've made it, man. You're here. You're live on YouTube, and I think we're on LinkedIn. So thank you so much. And please introduce yourself.
Yeah. Hi, I'm Ronnie Sahlberg. I work as a principal engineer in the kernel space at CIQ. I have a long background working with network file systems. So if you want to talk to me and it's not about kernel or network file system, yeah, my eyes will glaze over and I'll walk away.
Okay. Well, good to know what's happening. I will not take it personally when you walk away from me, Ronnie. I promise I won't take it personal. Oh, that's awesome. Okay. So we are going to dive into it now. First of all, I'd like to give a little overview. I mean, I kind of touched on a little bit of what the kernel is. Some people are not familiar with it. So let's just give a little overview. I think, Jeremy, you were going to do that, right?
Oh, so I mean, yeah, the Linux kernel is essentially the piece that mediates between the hardware and applications, and it's very important, and it's runs on just about everything. If you buy a television these days, it's running Linux. It runs the cloud. It runs in your car. If you have a Tesla, you're running Linux. It's one of the most, if not the most important pieces of software in the world, and it's full of bugs. And as it gets worked on, new bugs get added every day.
Yes.
So
New bugs. So I think you actually had some numbers, didn't you, Maple? Did you want to throw those numbers out right now we're talking about bugs?
Yeah, well, maybe not directly bugs, but for example, in our white paper, the Red Hat kernel or CentOS kernel we're based off of is based off of the Linux kernel version 4.18 for the 8 version, 5.14 for the 9 version, and I don't remember what the 10 is off the top of my head. That's coming out soon. From when CentOS first forked that, there have been little over 500,000 commits, so lines like changes to the kernel since it came out. Red Hat / CentOS for the 8.8, which is the main kernel we analyzed or did our graphs and stuff against, has about 95,000 commits in it. So it has about a fifth of the upstream, but not quite. And then I think the numbers were 5,000 known bugs in that subset. So proportionally, not exactly the same, but still equivalent. An interesting. So those are the numbers for that. We can kind of talk about, if we want, how we arrived at needing to look at this.
Well, I think we should mention that. That's kind of interesting because essentially we are rebuilding this kernel, and as part of the job of doing that, I think it was Ronnie who first started there. Oh, let's take a look at what gets fixed and what doesn't, which was actually the genesis behind the white paper that we published. That got a lot of comments on social media and various technical websites. Almost uniformly negative, might I add. People were very upset about it. But interestingly enough, out of all the comments, and I read most of them and responded to quite a few, there were many people criticizing the methodology and all the fact that we didn't consider this and consider that or whatever. But no one actually came out and said the numbers were wrong. And that was kind of interesting. So Ronnie, do you want to talk about how you arrived at this stuff? I mean, I wrote the white paper, but to be honest, the guys, at least on my screen below, Ronnie and Maple, did essentially all the work. So Ronnie, do you want to talk about how you got there?
Yeah, I was preparing my vacation and going away, and thought like, but actually now with all this really good stuff that Maple has built for us now with history and everything and understanding is that, I wonder if we could go and have a look at, like, well, can we identify bug fixes and can we identify things? Yeah, and let's have a look. Yeah, how hard can it be? It's just a small Python script, and then I ran it and was like, this is not right. So I looked at my Python script to find, because it was obviously broken and I couldn't find the bug. So I thought, okay, well, maybe this stuff Maple built was completely broken and just yeah, there was nothing wrong with his stuff either. So I was actually genuinely surprised that I did not expect this. I had preconceived notions about, for example, that when bugs are introduced in the kernel, they are very quickly identified and fixed, which sounds reasonable, but
turns out not to be true.
That is not true at all. So many bugs live a long time before they are. But anyway, that's that.
So the reason that we had this tooling set up is that when we provide CVE fixes for our customers' LTS, one of the things that we want to do is when we backport a CVE fix, we want to make sure that there are no known fixes for that specific CVE code. So we're not introducing a commit that also has known issues. So that's where this genesis of Ronnie's thing came from. And then what we did, he just sort of like, well, what happens if we run it against all the commits? We rebuilt. So we basically tried to replay all the changes that Red Hat made. There are some discrepancies and some things where they made specific changes that are not reflected in by upstream commits, because we just pulled back all the upstream commits they did and sort of rebuilt it in place. And so then we know exactly which upstream commits they used. They may be modified from their original one, but still the core of it's still there. That's kind of how we got there. And when Ronnie did this, we knew that this Linux kernel was going to be authoring CVEs itself, and basically said that anything that they considered a bug, so effectively, if a commit for a change has, I fixed this commit SHA in the past, that is, save some filtering, all bugs are considered CVEs, because this kernel lives in such a privileged space at the hardware and below user space that if you can exploit it, you can exploit anything on the system effectively.
So we should probably explain a CVE is a security bug.
Yeah, sorry, a CVE, a common vulnerability and exploit, is what it stands for.
Security bugs in the kernel.
Mm-hmm.
So I want to step back a little bit and just give an overview. First of all, if you haven't read the white paper and the blog post, go and do that, or at least record this, go read that, and then come back and watch the recording of this, because you won't understand what we're talking about.
We'll get the link for you too. We'll grab the link and we'll put it in the comments. Yeah.
But essentially what Ronnie and Maple were able to do was to look at the idea behind the vendor kernels. I call them frozen kernels in the blog post because I wanted to make frozen jokes, because I love that Disney movie.
And then now I need to sing. It's my turn to sing, right?
Go ahead, Rose.
Let it go, let it go.
Don't patch it up anymore. Yes. So the idea, and it's a very powerful and intuitive one, is that a vendor like Red Hat or someone else takes a snapshot of the Linux kernel code base, and they say, this is going to be our release for this particular stream. And then what they do is they only add to it specifically carefully selected pieces of code. And you would imagine, and the actual marketing behind that is, well, this makes it more secure because we start with a stable base, and it's true about the stability. What they have is very stable. But their argument is, and of course, because we carefully pick these commits for security purposes, we are slowly but surely eliminating security holes in the kernel. It's a very intuitive model. It's wrong. That's the problem with it. It kind of makes sense that, this stable kernel, you only add tiny little changes to it. It must be more stable and secure. Yes, it's more stable. It's not more secure. And that was basically the Ronnie was the first one to take his spectacles off and say, hang on a minute, the emperor has no clothes. It's not more secure. and that's the problem.
Yeah, I would be cautious to say that it's wrong because the idea behind it is correct. I think it's the longevity of it has
yeah.
When it was created 25 years ago ish, like to make sure that they could, be solidified in the enterprise, and the enterprise customers could reliably maintain Linux systems and drivers and all that sort of stuff, made total sense. Still makes sense, but
Yeah.
maybe not for the duration that they that some of the vendors do. We have examples of other vendors that go, this is a good idea, but we need to rev more quickly, like SUSE and AWS both do that.
Yeah.
So I know SUSE's moving to 6.4 in their next service pack, and I can't remember what AWS is at, but last I saw they were on 6.1 or 6.2.
The problem comes when you freeze a kernel and you put bug fixes into it from upstream. But what Ronnie and Maple were able to identify is that later on in upstream, which is where all development really occurs in Linus's particular kernel, there are fixes for the changes that they have already added. But those new fixes don't get added to the frozen kernel, to the vendor kernel. They don't get, at least as Ronnie found out, it's 5,000 or so. The white paper has the full details. And those fixes don't get added. Now, why is that a problem? Well, as Greg Crow-Hartman has pointed out, and Jonathan Corbett, the author of Linux Weekly News, almost any bug in a Linux kernel, if you're clever enough, can be turned into a security vulnerability. And there's some really clever people dedicated. We employ one of them, dedicated to a good old Solar, dedicated to actually looking for and turning these what would appear to be completely irrelevant, trivial bugs into security compromises. And because the Linux kernel these days runs everything, like I say, my car runs Linux, my music players run Linux, my hi-fi runs Linux. The monitor I'm watching you guys on almost certainly has a Linux kernel inside it. And bugs at that level can be incredibly dangerous. So the idea is, how do we get to a more secure base kernel for everybody in enterprise Linux? That's really the problem that we're trying to solve.
So there is the Linux kernel, which is open source, yes, and developed by the community. And then we're talking about a few different things, right? So there's the one that's being actively worked on, which what do they call that? Just
upstream, or Linus's tree, or
Linus's tree upstream. Okay, so
yeah,
that's the main one.
That thing has so many changes per day.
Right, constantly evolving. It's probably the newest, the best, or I don't know. Best.
Well, it's the most actively developed open source project in the world.
Okay. And then we have upstream stable kernel. Describe that.
Sure. Basically, you can treat like upstream mainline, like what the main Linux release is, as the development branch. And then they have a release branch, which is the minor version below it. So like they're actively working on 6.10 right now. The stable branch is 6.9 point something. So all the fixes that happen in development that Greg Crow-Hartman can pull into stable become bug fixes in stable. Now, that's when we get into the long-term discussions, which is a little bit more different, and probably a good reason as to why none of the they're kind of inconsistent with their numbering things, because numbering in the Linux kernel doesn't really actually mean anything. So yeah, so it makes it hard. So there's a long-term kernel for 6.6 and a long-term kernel for 6.1. And again, like stable, Greg Crow-Hartman and team go, what are the bug fixes that apply to this kernel, and bring it back. And they do that in the upstream. They provide it for everybody. But what they lose out on in those 3, 4 things that the Linux, like kernel.org, the official, upstream main development repository for it, is they don't maintain what is called the kernel application binary interface. And that is for, like, I have an NVIDIA driver, or I have a Mellanox driver, or I have a special, like, iSCSI driver, that their driver code is not inside the kernel, which is a very common thing to have. Those are usually built against specific versions, like the vendor kernels, where their interface into the kernel doesn't change or should have very minor changes. That guarantee is not ensured in anything in kernel.org currently.
Okay, so that's kind of one of the values and benefits that you guys were talking about of having a vendor kernel, is that it is, I don't know if guaranteed is the right word, but it is maintained in essence to kind of have some stability, and it works with your different drivers and other things that you want it to work with.
That's a lot less important than it used to be, because these days, when Linux was first started to be used in place of Solaris and AIX and all the old enterprise Unixes, that was a big problem for vendors, because they weren't going to open source their driver code. It's like, well, customers are asking us to make this work on this Linux thing. How can we do that? It's not even stable. And so, that was one of the reasons behind the vendor frozen kernel, was that, well, we can give you that stability. Now that Linux runs everything, there are not that many holdouts for getting their driver code into the Linux kernel. I mean, making a Wi-Fi card work in Linux used to be really hard. Now, just about every single Wi-Fi card in existence has drivers already upstreamed. The big holdout are NVIDIA, and Linus gave a very famous gesture to NVIDIA about that, which I shall not repeat. But he was upset about that. And there are a few others. But most of the vendors of enterprise hardware, they now understand how important it is to have their code inside the Linux kernel and externally maintained. Now, on the low end, that's different when you buy these little devices, and Android particularly, has suffered from this, but there's some interesting conversations we can have around how Android solves this problem. Many of the drivers for Android are out of tree, or at least. But for enterprise workloads, the big iron stuff, most of that code is now upstream. Not all. So there is less pressure on maintaining an in-kernel application binary interface, which is basically the interfaces inside the kernel that allow drivers not to be changed on every release. Now, I just want to make things very clear. This has nothing to do with running an application on top of Linux. Your Oracles and your SQL servers and all this stuff. They use the user space binary interface. Now, that is absolutely stable, as stable as the maintainers can make it. If you break the user space interface, you get a rant, and a really nasty one from Linus.
If you think any of us are opinionated, you go look at anything Linus has ever written.
When people break user space, it does still happen, but it's really rare. So what that means is that you can take an application that was written for Linux, even 3.x or 4.x kernel, you can run it without problems on a 6.x kernel, no problem at all. So do you want to talk about how Android solves things, Maple or Ronnie?
I don't know. What Android does is, Android, back in the day, every single Android, every vendor in the embedded space had their own special kernel that was incompatible with everything else. But they have evolved and gotten to the point now where the entire industry in that segment are actually using the upstream stable kernel, because all the vendors, they don't want to sit and maintain and backport their own private forks, because there are more interesting things you can work on if you're a kernel engineer than that. So they have pretty much united behind the upstream stable. And yes, there is there is the issue with, or the difficulty with, the kernel application binary interface not being super stable in Linux, but it's a solvable problem. And what Android demonstrates or shows is that the various Android vendors have, I think, around 300 different out of 3 modules, and they still get things to work even in face of the potentially unstable API. So all hope is not lost.
So they actually maintain a stable API or kernel application binary interface for stable. Google does that for the community. Or Android. I don't know the delineation at this point, but they do, like when Greg updates, they pull it in if the interface that they have identified, the pieces of the interface that they have identified that all their vendors like Samsung or LG or HTC, or I'm sure there's a million other ones. The interfaces that those vendors require to be stable, Android makes stable from the thing. And Greg Curl Hartman has mentioned that he helped them set that up, so they're aware of how to do that. Now, could we do that with an enterprise Linux where everybody has the same stable interface for their drivers and work off of a long term? And then that way everybody benefits from all the work that Greg and friends are doing. And then we can focus on, CIQ is focused, its original inception was around HPC. Can we focus more on HPC and specialized, like really custom interfaces that, we help our customers get their fixes upstream and stuff like that. Whereas, maybe if SUSE or AWS wants to join in on that and help support that, we all help support maintain the interface with kernel.org, and then they make theirs more, like SUSE makes theirs more targeted towards the general purpose, and AWS focuses on AWS hyperscaler stuff.
Oracle makes their database run really well.
Yeah.
So let me just try and understand this. Are you saying that that everyone pulls from stable, so the Linux mainline stable kernel, instead of having all the various vendor kernels that are only maintained for 6 months at a time?
That would be great.
Yeah.
That would be the goal. I mean, maybe OpenELA can do something.
I think that would be a very good solution for everyone, every single player in the industry to collaborate on that. I just say there is the issue with a stable kernel application binary interface, but I have no data about this. I'm just making up a statement here. I claim maintaining a completely stable API for these modules is significantly less effort than backporting the 1,203 CVEs that were issued last month alone.
So we can touch on that about the whole CVE numbers and stuff as well.
So Rose, you have to understand that the whole purpose of this white paper and everything is to try and move the industry so that Ronnie and Maple can do more interesting work.
Oh,
This may be greedy.
Yeah, so they don't have to spend their lives backporting, security vulnerabilities from upstream to. And the other thing, I want to point out is you can get the upstream kernels for any Linux distro. You can get them for Debian, you can get them from Rocky, you can get them. I know you can get them from SUSE, probably Oracle too. So this is not like, we want you to use a CIQ upstream kernel. No, just use an upstream kernel. I don't care where it comes from. It would make our lives so much, rather than backporting code that's already been written, we'd actually be able to work on new stuff, which is, the goal of all engineers, really. But yeah, do you guys want to talk about the CVE stream and how that has turned out and how that happened?
Sure. I've done a little bit of digging into this. So we just rebuilt the 8.10 CentOS base. And Red Hat / CentOS, like us, will include in their changelog for all of that, like what specific fixes that were introduced fix CVEs. For the entire life of 8 up to 8.10, there were 300 CVEs that they fixed. So that's 5 years, right? I'm sure some of the other bugs and back parts and stuff they did were technically CVE fixes, but no independent security researcher cut a CVE against them. Since February, the very beginning of February, with the new way that now the Linux kernel is the only people that can create CVEs against the Linux kernel. There have been over 2,000 new CVEs in just 4 months. And looking at the Red Hat analysis of it, over 1,000 of them impact CentOS 8 or Red Hat 8, and 600 of them impact Red Hat 9. I do not know how if they fixed them yet. It just right now they just have, yes, these are impacting. Does that mean that impact like our 8.6 or our 8.8? That's, further analysis you have to do, and you have for every single CVE, you have to compare it against every single one of your long-term support kernels. So like we have 8.6 and 8.6 RT, 8.8 and 8.8 RT, and then soon 8.10 and 8.10 RT, and then the 9 versions. So there's a lot of work and a lot of comparing code that you have to do just to fix one CVE across all of your products. Whereas if this was in the upstream, it just gets merged in by Greg, and then you suck it down and I'm done. Well, unless
you just merge it and then suck it down and you're done.
Yeah.
That is what makes Greg's kernels and the stuff he supports or provides so attractive, because if someone asks, do you have a fix for that CVE? Then you don't even have to check. You can just say yes. Because by definition, every single kernel CVE has already been fixed in his tree before the CVE is even published.
And actually, that might be a good thing to clarify for the stream, for those watching, is that CVEs or common vulnerability exploits are usually made when a security researcher is either very specifically looking into an area and discover something, and then they, tell somebody that they need to get that fixed, or they're looking at a fix that was introduced, like a code change that was introduced that fixes a bug, and then they see how they can exploit it. And then show, this bug is actually a CVE, and they get their like the security researchers, their whole currency for their profession is how many CVEs that are of certain quality did you recognize.
It sounds like an awesome job, actually, like a demolition person, but in like the tech world. Go in and
it requires a certain destructive mindset. Put it that way.
Yeah, there's no currency in having lots of CVEs attached to your name anymore, because Greg has won that battle already. He has 250 CVEs every week.
Yeah.
No one can compete anymore. It's over.
So the reason that they issue so many is essentially there are so many bugs that get fixed, they don't have time to analyze, could this be exploitable? The answer is usually yes, but it requires, to actually create an exploit and prove that it's a flaw that can cause a security issue, it's a lot of work. So it's easier to just assign a CVE, fix the bug, and move on. And so
that is true. If you pick a random CVE, it might be a lot of effort to fix them. I would rather just be more selective and just pick the CVEs where the commit message actually describes how you would exploit it.
Yes, there are some of those. Yeah.
So yeah, so to wrap it up, this whole paper, why we started looking at this was one, so we could maintain like doing this internally ourselves. I've worked at other companies where we've done it a weird way. We'll just leave it at that. And I didn't want to repeat that. And I wanted to be able to share those fixes across the various code branches easily. And the way we designed this allowed us to do that while we rebuilt the CentOS kernels and the minor release kernels, and then we are on our own after that. We don't have any access to what Red Hat is fixing in their extended support. So we have to make up all that difference, and that is a lot of work, and we wanted to try to minimize as much as possible. Yeah. But this kind of did expose, you're like, oh man, I like my, as bleeding edge as possible systems. That's all I run at home. But I understand why vendors or like commercial enterprises don't, but it might be time for the industry to start changing, especially now that the way that CVEs are being handled by the upstream or by the kernel.org, it's going to be overwhelming for most companies, or possibly everybody.
The number of CVEs are just such an enormous flow, but also the consideration that the process of CVEs are much, much different. In 2023 and earlier, like far back in the past, people would find a vulnerability, they would disclose it responsibly on mailing lists. There would be a 90-day grace period where everyone would fix it and then it would be published. That doesn't happen anymore. There is no grace period. If a vulnerability is found, it's published immediately.
Mm-hmm. Yeah.
It's not going to be 90 days where you can wait and then upgrade the kernel and have it fixed before it's published. Those days are over.
That means if you wanted to exploit things, you would literally cherry pick from Greg's CVE stream, look in older frozen vendor kernels for the same bug and go, oh yeah, I'll use that one today. To break into a system. So we really need to get customers used to updating more regularly and updating their kernels more rapidly, I think. Otherwise, they're going to get overwhelmed too.
So does an update require a reboot of the system, or is the idea of doing it in place update a different topic?
I can speak on this. So yes and no. There are features like Kpatch that allow you to patch the kernel and go, I got the source code I got from the RPM I installed the kernel with. This section here is vulnerable and I'm going to replace it with this one over here. Mm-hmm. And you can do that on a live system for certain classes of fixes, but not all fixes. What that allows you to do is defer your reboot, but you should still reboot. We don't offer it because we don't have the resources to be able to do that, because it is an exceedingly extra amount of work to be able to do that. It's non-trivial. However, I used to work with someone that was very, very intimate with how glibc works. So the base compiler for almost every, or base C runtime, which is the base of just about everything on a Linux system. And when he mentioned to me, he's like, oh yeah, you can update, but what happens to those applications that are running in memory that have the old exploitable version if they didn't get restarted after they were rebuilt with the update? And you're like, oh, that's a good point. Your RPM is updated, but your actively running binary is not. So rebooting on updates, absolutely best practice.
Yeah.
Now, downtime is usually the argument as why you don't, but yes, you should reboot. Kernel, especially just due to, firmware drivers, all this sort of stuff gets updated.
So I think another aspect on it is that while Ksplice and Kpatch are really, really interesting concepts, they were probably built for the scenario where you want to patch, you want to fix a CVE once a quarter or something and defer both. They weren't. The problem is scale. When you have a CVE being issued every 30 minutes, you can't really patch your kernel once every 30 minutes, like 24/7 forever.
Batch processing, Ronnie. Batch processing.
It's specifically, it includes like 300, and then next week there's another 300. And how well can that company providing the K-Splice or K-Patch stack those on top of each other?
Yeah.
Because then you start like having the kernel go through all sorts of different kernel spaces than what it was originally booted with. It's also more an representative of an era where everybody treated their servers as pets. So they didn't shut them down. They didn't get rid of them. Whereas the cloud has really rethought and SRE work, not just in the cloud with instances, but in physical bare metal data centers. Is you should just be able to, you should have enough resources and enough scheduling systems to be able to shut down your server, leave the other one up, bring it back up, and you still not impact your service customers.
Yeah.
So your server is effectively cattle. It's pets and cattle are usually the terminology, and it's easy to replace a cattle and not easy to replace a pet. And a lot of these systems were designed to replace pets and not cattle. And cattle, you just, there's a new image, just reboot it and
reboot.
Yeah.
So that may be one of the benefits of doing the vendor 6-month cycle, is that you really are only doing an update once every 6 months if you're kind of staying current.
Yeah, but that's where it's like, we have to take our server to the vet every 6 months to get it dewormed or whatever. Yeah.
Better than every 30 seconds.
To clarify, that 6 months is, I think, what the general increment for Red Hat stability guarantees, and 6 months is the minor version. So we have customers on 8.6, and I think we can say this, we've extended 8.6 lifetime for our LTS on that. We update that as we fix things. So we could have 1 week there's an update, and then the next week there's an update, and then it could be 2 months from now, and then you'll have 3 weeks in a row, for example. It's not just once every 6 months, it's as we release them. That's not the most predictable cadence, and there's the way that RPM updates and all that sort of stuff works in the industry is kind of going through how do we deterministically do these things, and there's a lot of ideas out in the industry, and I won't say any one specific one is better than another because I haven't done a full survey, but the kind of the older model, whereas the updates show up in your repo as we fix them, is kind of less ideal for some customers, or they'll hold off to only do it once a week or once every other week, or maybe they never do it. We can't do anything about that.
I mean, we have to start treating servers as essentially not long-term resources. They're short-term resources. You spin one up, you do something, you spin it down again. Pretty much the cloud model, which everyone is moving to. And you have the high availability means that you can have a certain percentage of them continually rebooting and the applications still keep running.
Yep.
And so that's the model that people are really already moving towards. But we need to treat the update of the systems in the same way. So it's really easy to say, I'm scheduling 10% of my servers to be updated this week. It's not going to affect anything. Everything else will keep running. I mean, occasionally if your electrical socket goes out, you use another one, and then you go and, flip the breaker in the garage or whatever. So, flipping the breaker in the garage is updating the server.
But you don't just stick a screwdriver in it and try and
you don't sort of say, I can't do anything until this particular socket works. You're just like, okay, I'll use another socket and I will reboot and fix the socket that's down right now. Is the way you have to think about it. Computing as a And that comes from the whole sort of computing as a resource you plug into the wall and get computing power, which is sort of the cloud model and the higher level model of the cloud. So yeah.
Unfortunately, I'm going to have to drop. I have to go to another meeting for some stuff. I want to leave with just my one thing. I am very adamant that all of the engineers at all of our respective companies are doing what they can with what the demands have been for the past 25 years. And there are cases of companies like SUSE and AWS, and I'm sure there are others that are trying to do the best they can. And we are internally grateful for all the work they've done setting that up in the industry. We saw this new CVE wall coming and how they were going to treat bugs and how so that's the genesis of this paper to maybe help create a new 2.6 model, which is how we got into this, the stability. And I'd love to be a part of that, working with all the other companies. I think we can all do something really amazing. But like I said, I need to drop, and you guys have fun afterwards. All right, talk to you later. Bye.
All right, thank you. See ya.
Yeah, I mean, even the white paper we explicitly called out, we're not trying to criticize the engineers and the work they do, because that's us too. We all do terrible work.
And great work.
Well, yes, occasionally it works. Yeah, but
I mean, also being responsive to your customers and what they're needing and wanting, and not just saying, well, this is what I think that you should do. This would be my best way of doing it. So that's your only option. And quite frankly, our customers are both, right? Like, we have people coming to us. I mean, obviously want to stay on CentOS for another year or two. People who want to be on 8.6 or, whatever it is, like be on a stable version. We've got plenty of people coming to us talking about the upstream stable versions and really wanting to kind of be on the cutting edge and do different things. And other companies that actually produce the drivers coming to us saying, hey, can we work on this together? So, I mean, quite frankly, it's a little bit split right now. So it's interesting to have this kind of a conversation where we're really talking about the pros and the cons and where we're going and what might be some best practices as we move together.
Well, the hope is to move more and more people to the upstream stable, because the burden of maintaining the older frozen kernels is going to get harder and worse. Eventually there's going to be some points where you're going to have there are security fixes that essentially you have to say for any company, you say these can't be fixed on this kernel. There are some changes that go, because Linux changes so much, the Linux kernel changes so much and so quickly. There are some things where you essentially have to say, no, this can't be done. You're easier just replacing the kernel with a more up-to-date upstream kernel from whatever source. This is not just a CIQ thing. And so, yes, we must respond to what customers want, but sometimes we do need to be able to lead them and say, what you're doing is not sustainable in the long term. And so here's a model we think would suit you better in the long term. Short term, of course, we will always help, but long term.
I mean, it makes sense, right? Yeah, because we're human, right? It's like, don't touch anything, don't do any. I'm busy. I don't have time to deal with that,
But in terms of, I'm reminded of a great cartoon I saw recently, published on many social media. It's a young engineer rubbing a magic lamp with a genie coming out, and the genie says, "You have one wish." And the engineer says, "I wish to learn everything there is to know about computer security." And the genie says, "Granted." And the next two panels, the engineer going, "Oh no." And the last one, "Oh God."
That's accurate. Every security person I ever talked to, they're like,
yeah, "Oh God, yes." It's worse than everybody thinks. Yes, that's such a great cartoon.
It's much worse than everyone thought. And also with the focus that we are starting to get on security in the kernel and CVEs, I think how the industry deals with security is going to change going forward, because just right now, the amount of CVEs being issued for the kernel has increased by a factor 50. That there are very few processes that can deal with a workload being scaled up by a factor 50 without
within
breaking.
a month or so. Yeah. So something has to change, but like I say, this isn't. All we're doing right now is pointing at the problem. There are many solutions, but we can't fix this on our own. We need to collaborate with everybody who's shipping enterprise Linux. And if we can all work together, we can make a better products, our products better for all customers, no matter who they purchase from. And that's, that's the ultimate goal.
Yeah. I like that. Well said. Well said, Mr. Jeremy. Yeah. All right. So, Ronnie, do you have any final thoughts you want to leave everybody with about the kernel?
Please, everyone, come join us work upstream with a stable branch, because there is no other.
Give Ronnie more interesting stuff to do.
Yeah, everyone. I hope the entire industry will just come together and work with upstream stable, because well,
the alternative is dire.
We need you. We want you. We love you. So where would somebody go to get involved with the upstream kernel? What do you call it? Kernel.org? Is that a good
well, the Linux kernel mailing list, but the trouble with the Linux kernel mailing list is it's a fire hose. So, getting involved in the Linux kernel, it's a hard job. It's a big program. It's very complex. Start small, like with any open source project. Find trivial things that, first of all, install Linux on your laptop or desktop or whatever. That's number one. Even if you're only running it in the Windows, they have a subsystem for Linux these days or whatever. Just start using it. I mean, that's goal number one, is to just get familiar. It's interesting. There are many computing science grads I talk to, universities, and they're learning all these sophisticated cloud techniques, but they're not sitting there running and using Linux on a day-to-day basis, and that's going to be their job when they graduate.
That is fair.
Systems, because it's everywhere. So yeah, I mean, just start using it, and then if you are interested. Again, the wonderful thing, that the change in the world from when I grew up, I had to join a Unix company to see Unix source code. These days, you can download it from a million sites on the internet. And this is the code that's running your cars. This is the code that's running your everything, all of the devices. So you can actually look at it. So if you want to learn, there has been no better time to learn. Problem is, of course, the amount to learn is very large. But that shouldn't be a problem if you start small, take bite-sized pieces, start to learn to understand this. It's complex, but it's really satisfying when if you make a first kernel change and you boot that kernel, the feeling of I did this is wonderful, and that's one of the beauties of open source. Is being able to make those changes, even if you're only running on your own hardware, and to feel the level of control you have over the stuff you're running. It's like, I can make a change. I'm not beholden to. I'm sorry, Rose. Going into the iStore, to the Apple Store, purchasing a pre-made iPhone that you are, Apple deigns you to be allowed to use. Linux is not like that. You can mess with the internals. So that's the fun part.
All right. I like it. Thank you,
My
Jeremy.
family also uses iPhones. I use an Android, of course, but my family uses iPhones, and I loathe having to support those things.
Well, it's nice to have options as well, right?
Indeed, it's like using a computer with mittens on.
You're awesome. I love it.
Sorry.
Well, so you guys working or watching here, thank you so much. If you want to talk about having a stable kernel, vendor kernel, we are happy to oblige, happy to chat with you. You can go to ciq.com, check out what it is that we do and get a hold of us. If you want to talk about the upstream stable kernel and getting involved with that, we also want to talk to you about that. It's kind of one of the fun things about being a tech startup is that we are also flexible and wanting to be out there doing the newest and the best. So come along on that little journey with us. Thank you guys. Ronnie, it is like the middle of the night for this guy. So just thank you so much for waking up with us.
It's soon sunrise.
Okay. The sun is just coming up.
Man.
Yeah.
I really appreciate you joining us, Ronnie. That's great because as I said, I wrote this stuff, but I didn't do any of the work, and I really need to point that out. Maple and Ronnie did all of the real work and the analysis on this.
Yeah.
So they're the ones who actually are producing the code that you run on your Rocky kernels and cloud kernels every day. So.
Yeah. Yeah. And it was such a great story too, Ronnie. Thank you for sharing that with us, where you're like, well, I just was curious. Right? I just thought, let me just look and see what I find. And that's
every great discovery starts with, that's funny.
Yeah. Yeah. That's right. Every good story starts there, and all innovation and forward movement starts with that kind of curiosity as well. Otherwise, we would just stay where we're at. So it's a really great conversation. I'm sure that we're going to have more things to talk about when it comes to the kernel. But thank you so much, both of you. Have a wonderful day, and we'll see you next week.
Yeah. And if anyone has any questions, feel free to post them on the YouTube comments or whatever, and we'll answer them as we get to it. So. Because I'm expecting that people who are going, what are these guys talking about? What is this thing? That might actually then go and read the paper. And
perfect.
And say, oh my God.
What are you people talking about? Yeah. Good times.
Yeah. All right.
All right. Well, thank you guys. Have a blessed day. Bye-bye.
Bye.